March 1943. Syracuse, New York. A production line supervisor named Harold Mitchell stood in front of a Blanchard grinding machine, holding two pistol slides. One from Colt's factory in Hartford, fitted to tolerances tighter than a watchmaker's dream. The other from his own Remington Rand assembly line, with clearances that would make a master gunsmith wince. Both pistols fired 6,000 rounds without a single malfunction. Mitchell stared at the slides, trying to understand what he was seeing. For 30 years, American gunsmiths had believed precision meant tightness, tight tolerances, perfect fits, parts machined so closely together that only skilled craftsmen could assemble them. But John Browning had designed something different, something that seemed wrong to every instinct Mitchell had learned in his 20 years of manufacturing. The Colt slide had been hand-fitted by a machinist who spent 45 minutes ensuring every surface mated perfectly. Remington Rand slide had been ground by a machine in 6 minutes, with tolerances 3 times as loose, and somehow, impossibly, the sloppy one worked better. Mitchell kept thinking about what the Ordnance Department inspector had told him that morning. The Germans build Lugers like Swiss watches, the Japanese build Nimbus like works of art, and both of them jam in mud. Your ugly American pistol just keeps firing. Mitchell understood manufacturing. He understood machines and tolerances and precision metalwork, but he did not understand this. How could a pistol designed with loose, sloppy tolerances outperform weapons built to jewelers' standards? How could Browning's deliberately crude clearances create the most reliable combat pistol ever made? What happened next would transform not just firearms manufacturing, but American industrial philosophy itself. The Remington Rand factory would produce more 1911 pistols than any other manufacturer in history, nearly 900,000 by war's end. They would do it faster, cheaper, and with better interchangeability than companies that had been making firearms for generations. And they would do it by embracing what every machinist had been taught to avoid: sloppiness. Brownina's genius was not in what he tightened, it was in what he deliberately left loose. To understand how a typewriter company revolutionized firearms production, you need to understand where the 1911 came from, and why John Moses Browning built intentional imperfection into America's most successful combat pistol. 1905. Colt's Patent Firearms Manufacturing Company, Hartford, Connecticut. John Browning presented his latest prototype to Army Ordnance officials, a .45 caliber semi-automatic pistol that looked like nothing they had ever seen. The Ordnance Department had specific requirements. American forces in the Philippines were facing Moro warriors who kept fighting after being shot with .38 caliber revolvers. The Army needed stopping power, real stopping power. Browning's design delivered. His .45 ACP cartridge hit like a freight train. But the Army inspectors noticed something else, something that troubled them. The pistol's internal tolerances were loose, not sloppy, exactly, but nowhere near the precision of European pistols like the Luger or Mauser. There was visible play in the barrel bushing. The slide rattled slightly on the frame. The disconnector had clearances that would never pass inspection in a German armory. "Mr. Browning," one inspector said, holding up the prototype, "your tolerances seem rather generous." Browning smiled. That Kansas farm boy smile that drove engineering purists crazy. "They need to be," he replied. "A soldier cannot clean his pistol with a jeweler's tools in a muddy trench." The inspector did not understand. None of them did. Not yet. European pistol design followed a different philosophy. German and Austrian engineers built firearms, like precision instruments, tight tolerances, perfect fits, components machined to within thousandths of an inch. These pistols were accurate. They were beautiful. They were mechanical marvels. They also jammed constantly in field conditions. Browning understood something European designers missed. Precision and reliability were not the same thing. In combat, pistols got dirty. Soldiers dropped them in mud, sand, seawater. They fired them with cold hands, injured hands, hands shaking from fear and adrenaline. They cleaned them with whatever was available, oiled them with whatever they could find, reassembled them in darkness. A pistol that required perfect conditions to function was useless in war. So Browning built intentional sloppiness into his design. The barrel bushing had extra clearance so dirt could not lock it up. The slide to frame fit was loose enough that sand could shake free instead of jamming the action. The disconnector gap was wide enough that a thick coat of lubricant or a thin layer of rust would not prevent operation. Every clearance in Browning's pistol was calculated, not to achieve perfection, but to guarantee function under the worst possible conditions. The Army conducted trials in 1910. Browning attended personally, watching as his pistol fired 6,000 rounds over 2 days. When the frame grew too hot to touch, they dunked it in a bucket of water and kept firing. No malfunctions. The competing Savage pistol, built to tighter tolerances, suffered 37 failures. On March 29, 1911, the Army adopted Browning's design as the Model 1911. Nobody realized it yet, but Browning had solved a problem that would not fully reveal itself for 3 more decades. He had designed a pistol that could be mass-produced by companies that knew nothing about firearms. If you are enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Between 1911 and 1917, Colt and Springfield Armory produced about 100,000 M1911 pistols. Production was traditional. Skilled machinists hand-fitted components. Master gunsmiths assembled and tested each weapon. The pistols were excellent. They were also expensive and slow to manufacture. Then America entered World War I. Suddenly, the Army needed pistols. Not hundreds, not thousands, millions. Colt could not keep up. Neither could Springfield Armory. The Ordnance Department issued contracts to other manufacturers: Winchester, Remington, National Cash Register, Savage Arms, North American Arms. The contract specified that parts must be interchangeable. Any M1911 part should fit any M1911 pistol, regardless of who manufactured it. It was a disaster. Colt's technical drawings contained nominal dimensions but no tolerances. Different manufacturers interpreted the drawings differently. A barrel from Remington would not fit in a Colt frame. A slide from Winchester would not work with a Springfield receiver. The problem was not the manufacturers. They were skilled companies with modern equipment. The problem was that nobody understood what made Browning's design work. They saw the loose tolerances as mistakes to be corrected, not features to be preserved. Winchester tried to improve the design by tightening clearances. Their pistols jammed constantly. National Cash Register attempted to use precision Swiss machinery. Their parts would not interchange with Colt's. Remington UMC managed to produce 20,000 pistols before the war ended, but even their parts did not fully interchange with Colt's production. The Army ended World War I with a mess. They had M1911 pistols from multiple manufacturers, but armories could not reliably swap parts between them. Worse, nobody had documented which tolerances mattered and which ones did not. The specifications existed, but the knowledge behind them had stayed locked in Browning's head and Colt's shop floor experience. Between 1918 and 1940, the Army worked on standardization. They gathered pistols from different manufacturers and carefully measured every component. They discovered something fascinating. The tightest tolerance pistols were not the most reliable. In fact, tight tolerances often reduced reliability and made parts interchange worse. Colt had decades of experience building Browning's design. Their machinists knew through trial and error which fits needed to be snug and which needed to be loose. But that knowledge was informal, passed from master to apprentice, not written down in engineering specifications. In 1926, the Army adopted the M1911 Aone, a slightly modified version of the original 1911. The modifications were minor: a shorter trigger, an arched mainspring housing, a relieved frame behind the trigger. But the real work was happening behind the scenes. Springfield Armory engineers created new technical drawings based on Colt's actual manufacturing process, not on theoretical ideals. They documented every tolerance, every clearance, every fit. They created gauges to verify dimensions. For the first time, the Army had complete, accurate specifications for mass production. The specifications captured Browning's genius. Tight tolerances where they mattered for safety and function, the breech face, the locking lugs, the firing pin, loose tolerances where they mattered for reliability, the slide to frame fit, the barrel bushing, the magazine well. The new specifications would not be tested until the next war, a war that would require pistol production on a scale that made World War I look like a small batch operation. December 7th, 1941, Pearl Harbor. America was at war again. The army needed pistols immediately, not tens of thousands, millions. Running 24 hours a day. It was not enough. The Ordnance Department needed more manufacturers, but they had learned from World War I's mistakes. This time they had proper specifications. This time they would choose manufacturers carefully. In January 1940, the Army gave Singer Manufacturing Company an educational order for 500 M1911A1s. Singer made sewing machines, not firearms. The contract was a test. Could a company with zero firearms experience produce military pistols using the new standardized specifications? Singer delivered 500 pistols by December 1941. They were excellent, high quality, fully interchangeable with Colt production. But Singer's expertise was needed for other war production. The company stopped making pistols and sent all their tooling to another manufacturer, Remington Rand Incorporated. Remington Rand made office equipment, typewriters, adding machines, business forms. They had massive manufacturing capacity. Modern production facilities, experienced machinists, and absolutely no idea how to make firearms. In March 1942, Remington Rand received a contract for 125,000 M1911 pistols. Harold Mitchell, the production supervisor, looked at the specifications and felt his confidence drain away. He had spent his career manufacturing typewriters, precision mechanisms with tight tolerances and careful adjustment. Now he was supposed to make pistols, combat weapons, and the specifications were insane. The slide to frame fit specification called for tolerances of plus or minus 0.005 of an inch. In typewriter manufacturing, that was garbage. You would never accept such sloppiness. The barrel bushing specification was even worse, 0.008 of an inch clearance. Mitchell could not believe it. That much play and the barrel would wobble like a loose tooth. The disconnector clearance was 0.15 of an inch. 15. Mitchell had rejected typewriter parts for being 0.003 out of specification. Now he was supposed to build pistols with clearances 5 times larger. He assumed there was a mistake in the drawings. There was not. Mitchell and his team set up their production line using equipment transferred from Singer, Springfield Armory, and Harrington and Richardson. They received technical assistance from both Colt and Springfield Armory. They studied the specifications, the gauges, the assembly procedures, and they started producing pistols. The first batch came off the line in November 1942. Mitchell inspected them carefully. The tolerances matched the specifications perfectly, which meant by typewriter standards they were sloppy. The slides rattled on the frames. The barrels had visible play in their bushings. The whole pistol felt loose, almost crude. Mitchell expected them to fail. They did not. They passed every test. Accuracy testing, function testing, durability testing. The loose, sloppy Remington Rand pistols worked exactly like the hand-fitted Colt pistols. Better, actually, because the Remington Rand pistols were truly interchangeable. You could grab parts from 3 different pistols, assemble them together, and have a working firearm, something that was still difficult with hand-fitted Colts. But Mitchell still could not understand why it worked. Everything in his experience said tight tolerances made better products. Then, in March 1943, the Army shut down Remington Rand's production line completely. Parts from different production batches were not interchanging properly. Mitchell thought his career was over. Instead, the shutdown became his education. Ordnance Department engineers descended on the Syracuse plant. They did not just inspect, they taught. They explained Browning's design philosophy. They showed Mitchell which tolerances actually mattered and why. The breech face had to be square and precisely located. That was safety. If the breech face was misaligned, the cartridge could rupture during firing. The locking lugs on barrel and slide had to mate correctly. That was function. Those lugs held the barrel and slide together during firing and absorbed enormous stress. But the slide to frame fit? That could be loose. Dirt and debris needed somewhere to go. The magazine well? Wide tolerances were fine. Soldiers needed to reload quickly in darkness with cold or injured hands. The barrel bushing? The extra clearance prevented binding if the barrel got hot or dirty. Mitchell started to understand. Browning had not designed a precision instrument. He had designed a tool that had to work when it was dirty, when it was damaged, when it was maintained by exhausted soldiers using inadequate equipment. Tight tolerances made precision. Loose tolerances made reliability. The choice was not about quality. It was about purpose. After the shutdown, Remington Rand's production restarted with new manufacturing procedures and better quality control. The Army had taught Mitchell and his engineers which measurements to monitor closely and which ones did not matter. Now the pistols coming off the line were not just reliable, they were perfectly interchangeable. By the end of 1943, Remington Rand had figured something out that even Colt had not fully mastered. How to build Browning's design exactly as intended, not better, not tighter, not more precise, exactly as designed, and production exploded. 1944. Remington Rand's Syracuse plant was producing .45 caliber pistols faster than any manufacturer in American history. The numbers were staggering. In 1944 alone, Remington Rand manufactured nearly 560,000 M1911 pistols. That was more than Colt's total production from 1911 to 1941. Mitchell watched the assembly lines with something approaching awe. Blanchard grinding machines shaped slides in 6 minutes instead of 45. Unskilled workers assembled pistols using foolproof fixtures and gauges. High-standard supplied barrels. Other contractors provided small parts. Everything flowed together with the efficiency of a typewriter factory, because that was exactly what it was. Remington Rand had taken their experience in mass-producing office equipment and applied it to firearms. They used straight-line manufacturing, moving work from station to station rather than having craftsmen build complete pistols. They used specialized fixtures that made assembly foolproof. They used gauges to verify dimensions rather than relying on craftsman's skill. Most importantly, they trusted Browning's specifications. They did not try to improve anything. They did not tighten tolerances to improve accuracy. They did not hand-fit components to reduce rattle. They built the pistol exactly as specified. Loose slide to frame fits, wide, clearances in barrel bushings, generous magazine wells, and those sloppy pistols just kept working. Soldiers loved them. Armorers loved them. Because when a part broke in the field, any part from any manufacturer would fit. A barrel from High Standard would work in a Colt frame. A slide from Remington Rand would work on an Ithaca receiver. The entire logistics system was simplified. Instead of needing specific parts for specific pistols, armories could stock generic M1911 components. A broken pistol could be repaired using parts from 3 different manufacturers. This was the holy grail of military firearms, true interchangeability, and it only worked because Browning had designed sloppiness into the system. Other contractors struggled with the same lessons. Ithaca Gun Company built beautiful sporting firearms with tight tolerances. Their M1911A1s worked fine, but they could not match Remington Rand's production speed or costs. Union Switch and Signal had similar struggles. Both companies tried to apply traditional gunsmithing standards to military production. Remington Rand succeeded because they were not gunsmiths, they were manufacturers. They understood that mass production required different thinking than craft production. You could not hand-fit 800,000 pistols. You had to design the product so it did not need hand-fitting. Browning had done exactly that, 30 years before anyone needed it. By the end of 1944, The Ordnance Department was sending inspectors from other countries to study Remington Rand's operation. British, Canadian, even Soviet observers wanted to understand how a typewriter company was outproducing everyone else. The secret was not machinery. Remington Rand used standard equipment available to any manufacturer. The secret was not skilled labor. Most of Remington Rand's workers had never touched a firearm before the war. The secret was philosophy. Remington Rand built the pistol as designed, not as they thought it should be. They trusted that a genius designer had reasons for his choices, even when those choices seemed wrong. October 8, 1918. Châtelchery, France. Corporal Alvin York crouched behind a tree on a hillside in the Argonne forest. His patrol had captured German prisoners, but now they were under heavy fire from machine gun nests. York's rifle was empty. 6 German soldiers saw their opportunity and charged him with bayonets fixed. York drew his M1911, 6 shots, 6 dead Germans. 1 bullet per man, fired so fast the survivors thought there were multiple shooters. York would later explain his technique. He shot the last man in line first, then worked forward. That way the men in front kept charging, not knowing their comrades behind them were falling. Basic tactics from turkey hunting back in Tennessee. Except turkeys did not shoot back. The German officer commanding the position watched York methodically kill his men. When York pointed the .45 at his head, the officer surrendered, along with 132 of his soldiers. York marched them all back to American lines, his M1911 loaded and ready. The pistol had 7 rounds. York faced over 100 armed enemy soldiers, but those 7 rounds were enough. Because every German soldier knew what that .45 caliber bullet could do. This was not isolated. Lieutenant Frank Luke, the Arizona balloon buster, was shot down over German territory. Surrounded by enemy infantry, he used his M1911 until he ran out of ammunition. Then he kept fighting with his fists. They found 7 dead German soldiers around his body, all shot at close range with his pistol. Colonel Walter Walsh, an FBI agent turned army officer, spotted a Japanese sniper firing from a bunker on Guadalcanal, 75 yards away. Walsh aimed his M1911 carefully and fired. 1 shot through the firing slit. The sniper never fired again. His fellow officers thought it was luck. Walsh proved otherwise by doing it twice more during the campaign. The M1911 was saving lives in ways Browning never anticipated. Second Lieutenant Owen Baggett's B-24 bomber was shot down over Burma. He bailed out, but Japanese fighters began strafing the parachuting aircrew. Baggett played dead, hanging limp in his harness. A Zero pulled alongside to confirm the kill. The pilot opened his canopy for a better look. Baggett drew his M1911 and shot the pilot in the head. The Zero spiraled into the jungle. Baggett became the only man in history to shoot down an aircraft with a pistol while parachuting. These stories spread through American forces. The M1911 was not just a sidearm, it was a lifeline. The difference between capture and escape, between death and survival. And every soldier who carried one knew it worked because of those sloppy tolerances. The pistol that survived being dropped in mud, soaked in seawater, buried in sand. The pistol that fired when everything else failed. Technical inspectors examined M1911s returned from combat. They found pistols that had fired thousands of rounds without cleaning, pistols with rust visible on internal parts, pistols missing small components that had been lost or damaged. All of them still functioned. The inspection reports always reached the same conclusion. The loose tolerances allow continued function despite neglect, damage, or component wear. A pistol built to jewelers' tolerances would have seized up after 100 rounds without cleaning. The M1911 kept firing for thousands. A precision-fitted pistol would have jammed when sand got in the action. The M1911 shook it out and kept working. This was the revelation that changed everything. Reliability was not about precision. It was about resilience. Browning had designed resilience into every clearance. The barrel to bushing fit had 0.08 of an inch clearance. That gap let dirt escape instead of jamming the mechanism. The slide-to-frame fit had 5/1000ths clearance. That space accommodated thermal expansion when the pistol got hot. The disconnector had 15/1000ths clearance. That tolerance ensured function, even with heavy deposits of carbon or lubricant. Every loose tolerance served a purpose. Every gap in the fit was intentional. Browning had calculated exactly how much sloppiness each component needed. Not to make manufacturing easier, though that was a benefit, but to guarantee the pistol worked when covered in mud, frozen solid, or red-hot from continuous firing. Harold Mitchell finally understood this completely by mid-1944. He had been building pistols for 2 years. He had seen the production numbers climb into the hundreds of thousands, but understanding came slowly, through experience and observation. One incident crystallized everything. A batch of slides came off the Blanchard grinder with slightly tighter tolerances than specified, within specification, but on the tight side. Mitchell's quality control inspectors flagged them. They fit well. They looked better than the deliberately loose slides. Mitchell was tempted to approve them. Then he remembered the Ordnance Department shutdown in '43. He remembered the lectures about Browning's design philosophy. He rejected the entire batch. The ordnance inspector asked why. These slides meet specification. They are actually better fitted than normal production. Mitchell shook his head. They are within specification, but on the wrong side of the tolerance band. Browning designed this pistol to be loose. Tighter is not better, it is different, and different means unreliable in field conditions. The inspector smiled. You are understanding why the specifications exist. That understanding transformed Remington Rand into the premier M1911 manufacturer, not because they made the best pistols, because they made the right pistols, pistols that matched Browning's vision exactly. The production line workers could feel the difference. Early in production, they had instinctively tried to improve fits, to tighten clearances, to make prettier pistols. By 1944, they had learned to resist that instinct. They built exactly to specification. No tighter, no looser. Exactly as Browning designed it. And the pistols that came off the line worked flawlessly. Harold Mitchell finally understood what he had been seeing all along. Browning had not compromised quality for ease of manufacture. He had designed quality that could be manufactured. Those loose tolerances were not flaws. They were the design's most important feature. They were what made the 1911 the most successful military pistol in history. If you find this story engaging, please take a moment to subscribe and enable resultant notifications. It helps us continue producing in-depth content like this. The production numbers from World War II are almost difficult to believe. Remington Rand manufactured 877,751 M1911 Aoni pistols. Colt produced about 430,000. Ithaca produced about 400,000. Union Switch and Signal produced 55,000. Singer produced 500 for testing. Total production exceeded 1.8 million pistols. But the numbers only tell part of the story. What mattered was that those 1.8 million pistols shared truly interchangeable parts. A soldier in the Pacific could repair his Ithaca pistol using parts from a broken Remington Rand. An armourer in Europe could rebuild a Colt using components from Union Switch and Signal. The logistics system was simplified. The supply chain was streamlined. Soldiers had confidence that their sidearms would work and could be repaired. All because John Browning understood that combat reliability required different design choices than target accuracy. All because he built deliberate looseness into critical clearances. All because he trusted that soldiers needed tools, not jewelry. But the story was not finished. There was still one more surprise waiting, one more revelation about what Browning had really created. And it would not be fully understood until decades after his death. August 1945. The war ended. Production contracts were cancelled. Nearly 2 million M1911 Aoni pistols sat in government arsenals. Nobody ordered new production. Nobody needed to. The stockpile was enormous. But here was the remarkable thing. Those pistols kept serving. Korea, Vietnam, Lebanon, Grenada, Panama, Desert Storm. Soldiers in 1991 were carrying pistols manufactured in 1943. 48 years of continuous service. Pistols that had been rebuilt multiple times. Pistols whose original parts had been replaced with components from 3 different manufacturers. Pistols that had fired hundreds of thousands of rounds, and they still worked. That was Browning's final gift. He had designed a pistol that could survive longer than the wars it fought in. The Army conducted studies after World War II. They wanted to understand why M1911A1s remained so reliable despite decades of hard use. The conclusion was surprising. The loose tolerances that had enabled mass production also enabled longevity. When parts wore out, they wore evenly. When clearances increased through use, the pistol still functioned. You could take a frame manufactured by Colt in 1918, a slide from Remington Rand in 1944, a barrel from High Standard, internal parts from Ithaca, and assemble a working pistol. The sloppy tolerances meant parts did not need to fit perfectly. They just needed to be within specification. A specification deliberately designed to accommodate wear, damage, and imperfect maintenance. In Korea, where temperatures dropped to 40 below zero, 1911A1s kept firing when other weapons froze. In Vietnam's heat and humidity, where rifles jammed constantly, the old Colt 45s just worked. Tunnel rats crawling through Viet Cong tunnels in pitch darkness carried nothing but a flashlight and their 1911. They trusted those loose tolerance pistols with their lives, and the pistols never let them down. But Korea deserves special attention, because Korea proved something that even 2 world wars had not fully demonstrated. The M1911 could function in conditions that destroyed other weapons. November 1950, Chosin Reservoir, North Korea. The temperature hit 30 below zero. Wind chill drove it lower. Marines of the 1st Division were surrounded by Chinese forces. Rifles froze. Machine guns seized up. Even the new Moni carbines stopped functioning in the cold. But the M1911A1s kept working. Brigadier General Samuel Marshall toured the Chosin front. He interviewed hundreds of Marines about their weapons. His report was stark and clear. One hears more words said of the M1911's proved usefulness than during either World War. The pistol just works. In temperatures that freeze gun oil solid. In conditions that crack rifle stocks. The 45 keeps firing. Marshall investigated why. He discovered that the loose tolerances were the key. When oil froze, the wide clearances let the pistol function dry. When metal contracted in the cold, the generous fits accommodated the changes. When soldiers' hands were too cold and numb to manipulate small controls, the big, simple controls of the 1911 still worked. Sergeant Ernest Coomer's experience demonstrated the pistol's versatility. His tank was surrounded by North Korean forces. He fired the 50 caliber machine gun until it ran empty. Then he grabbed his M1911, Aoni. For 9 hours, he fought off waves of enemy soldiers. He fired his pistol until it was empty, reloaded, fired it empty again, over and over. When the battle ended, he had killed an estimated 250 enemy soldiers. His tank was intact, his pistol still functioned. The Medal of Honor citation mentioned his pistol specifically, because in that frozen hell, it was the only weapon that never failed him. Other soldiers reported similar experiences. Lieutenant Joseph Owen commanded a mortar section at Chosin. When Chinese forces overran their position, the Marines fought hand to hand. Owen's pistol fired flawlessly, despite being coated in ice. He would later write that the M1911 saved his life 3 times in one night. The Navy Crosses and Silver Stars from Korea mentioned M1911s repeatedly, always in the same context. The pistol worked when nothing else did. This was validation of everything Browning had designed, everything Harold Mitchell had learned to build. The sloppy tolerances were not just for manufacturing efficiency. They were not just for ease of maintenance. They were for survival in the worst possible conditions. Engineers at Springfield Armory analyzed M1911A1s returned from Korea. They found pistols that had been fired in temperatures ranging from 40 below to 120 above. Pistols that had been submerged in rice paddies and frozen in mountain streams. Pistols that had been dropped, run over by vehicles, and buried in avalanches. All of them still worked. The engineering reports documented something remarkable. The average M1911 Aoun maintained 80% of its original specifications after firing 10,000 rounds under combat conditions. Other pistols showed 50% degradation after 5,000 rounds. The difference was those loose tolerances. As parts wore, the clearances increased slightly, but they started from a generous baseline. A pistol, designed with tight tolerances, lost function as it wore. A pistol designed with loose tolerances just got slightly looser and kept working. This was genius that transcended manufacturing. This was engineering for the real world, for the world where maintenance happens in foxholes, where cleaning happens with dirty rags and whatever oil you can scrounge, where parts wear out and cannot be replaced for months. Browning had designed for that world, even though he never fought in it. Even though he died before seeing his pistol tested in the worst conditions imaginable, he understood that combat was chaos, and chaos required resilience, not precision. By 1953, the Korean War had ended. The M1911 Aoun's reputation was untouchable. Every branch of service trusted it completely, but America's NATO allies were pushing for standardization on 9mm ammunition. The Army began studies on whether to replace the .45. The studies always reached the same conclusion. The M1911 Aoun is superior in stopping power and reliability, but NATO standardization requires 9mm. The debate continued for 30 years. Through Vietnam, through countless small conflicts, the M1911 kept proving itself. In the Vietnamese tunnels, Sergeant Ronald Payne carried only his pistol and a flashlight. He volunteered for tunnel rat duty because he trusted his 1911 completely. In total darkness, crawling through spaces barely wide enough for his shoulders, knowing the Viet Cong waited ahead. His .45 was his only defense. Other tunnel rats agreed. The M16 was too long for tunnel combat. The Mon carbine was better but still awkward. The M1911 was perfect. Short, powerful, utterly reliable. And the loose tolerances meant it still functioned after being dragged through mud, water, and filth. Navy SEAL Thomas Norris used his M1911 to fight off Viet Cong while rescuing a downed aircrew. He fired it dry, reloaded under fire, fired it dry again. When extracted by helicopter, his pistol was covered in mud and blood. It still functioned perfectly. These were not exceptional cases, they were typical. Thousands of soldiers, Marines, sailors, and airmen carried M1911 A1s through Vietnam. All of them reported the same thing. The pistol just worked. Some had been manufactured in 1918, 50 years old, rebuilt multiple times, fired hundreds of thousands of rounds, still working, still saving lives. This longevity revealed another layer of Browning's genius. The loose tolerances that enabled mass production also enabled extreme longevity. Parts wore gradually and evenly. When they wore out, they could be replaced with parts from any manufacturer. The pistol did not need to be rebuilt as a complete unit. Individual components could be swapped as needed. An armourer could take 3 broken pistols and make 2 working ones, using parts from Colt, Remington Rand, and Ithaca interchangeably. This was unprecedented in firearms design. Most pistols needed matched parts. Parts from one manufacturer would not fit in another manufacturer's pistol. The M1911 transcended that limitation. Because Browning's loose tolerances created such generous fits that slight variations between manufacturers did not matter. A barrel bushing from high standard fit perfectly in a Colt frame. A slide from Remington Rand worked flawlessly on an Ithaca receiver. This interchangeability revolutionized military logistics. Instead of maintaining separate parts inventories for each manufacturer, armories stocked generic M1911 components. Instead of tracking which pistol came from which maker, they just fixed whatever broke. The entire supply chain was simplified. By 1970, military planners were looking for a replacement. The M1911 was old-fashioned, single action only. 7-round magazine. Heavy. Steel construction. Modern pistols had double-action triggers, higher capacity magazines, lighter alloy frames. NATO wanted standardization on 9mm ammunition. Political pressure mounted to adopt a more modern design. In 1985, the Army officially replaced the M1911 with the Beretta M9, a modern, high-capacity 9mm pistol. The Marines followed in 1986. After 74 years, the Browning design was officially retired from standard service. Except it was not really retired. Special Operations Forces refused to give up their .45s. They had experienced the difference in combat. A 9mm might wound an enemy. A .45 caliber stopped them. Marine Force Reconnaissance, Navy SEALs, Army Special Forces. They kept their M1911A1s and demanded updated versions. The Marines created the M45 MEU SOC pistol, hand-selected M1911 AON frames, rebuilt with modern components. The Army developed the M45 AON. Colt produced special variants for special operations. The 1911 refused to die. Because when your life depends on your sidearm, you choose reliability and stopping power over magazine capacity. Harold Mitchell lived to see it all. He retired from Remington Rand in 1967 after 40 years in manufacturing. He kept one of the first pistols his line produced, serial number 786,000. He never fired it. He just kept it as a reminder that sometimes the right answer looks wrong, that precision and quality are not always the same thing, that the best design is not the tightest design. It is the design that works. Mitchell died in 1993 at age 88. By then, Remington Rand no longer existed. The company had merged and changed and disappeared into corporate history. But Mitchell's pistols were still in service, still protecting American soldiers, still functioning exactly as John Browning had designed them 80 years earlier. The M1911 story reveals something profound about American manufacturing philosophy. European firearms makers built precision. American manufacturers built reliability. Europeans made weapons that functioned perfectly in ideal conditions. Americans made weapons that functioned adequately in all conditions. It was not about who made better guns. It was about who understood their purpose better. A German Luger was a mechanical masterpiece. Tight tolerances, perfect fit, exquisite craftsmanship. In clean conditions on a test range, it was more accurate than an M1911, but in a muddy French trench in 1918? The Luger jammed. The M1911 fired. A Japanese Nambu was beautifully made. Precise machining, careful assembly, complex and elegant, until you dropped it in coral sand on a Pacific island. Then it stopped working. The M1911 shook the sand out and kept firing. Browning understood something fundamental. War is not conducted in ideal conditions. Weapons do not stay clean. Maintenance is performed by exhausted soldiers with inadequate tools. Parts wear out. Damage happens. A weapon designed for perfection fails in reality. A weapon designed for reality succeeds in war. This philosophy extended beyond firearms. American tanks in World War II were not as heavily armoured as German Tigers. They were not as powerful, but they were reliable. They could be repaired in the field. They kept running. American aircraft were not as manoeuvrable as Japanese Zeros. They were not as fast, but they brought their pilots home. They could absorb damage and keep flying. American ships were not as individually impressive as Japanese battleships, but they were mass-produced. They could be built by shipyards that had never made warships before. This was America's secret weapon. Not superior individual equipment. Not tighter tolerances or better craftsmanship. Mass producibility. Reliability. The ability to make good enough equipment to overwhelm enemies who made small quantities of perfect equipment. The M1911 embodied this philosophy in steel. Browning had designed it in 1905, but he had designed it for wars that would not be fought until 1944. He had designed it for manufacturing methods that did not exist yet. He had designed it for a world where typewriter companies would need to make pistols. He had designed sloppiness as a feature, not a bug. By the early 21st century, the M1911 was over 100 years old. Most firearms designs lasted a decade or two before being replaced. The M1911 had served through 10 decades. It had fought in 2 world wars: Korea, Vietnam, Lebanon, Grenada, Panama, the Gulf War, Afghanistan, Iraq. It had been carried by millions of soldiers. It had saved countless lives. And it was still in production, not just by Colt, by dozens of manufacturers worldwide. The patents had expired decades ago. Anyone could make a 1911, and many did. From high-end custom shops building $5,000 competition pistols to budget manufacturers making $400 entry-level guns, everyone was making 1911s. All of them following Browning's original design, all of them proving that good design is timeless. Modern pistol manufacturers tried to improve on Browning's concept. They added double-action triggers. They used polymer frames. They increased magazine capacity. They added rail systems for lights and lasers. Some improvements stuck, many did not, because Browning had gotten the fundamentals right: the grip angle, the trigger reach, the balance, the reliability through loose tolerances. You could add accessories, you could modify details, but the core design remained untouchable. In 2012, the Marine Corps adopted the M45 close-quarter battle pistol, a modernized M1911A with night sights, rail system, and updated components. But the basic design? Pure Browning. Loose slide to frame fit, wide barrel bushing clearances, generous tolerances throughout. 101 years after adoption, the Marines were still trusting their lives to John Browning's deliberately sloppy pistol. The firearms industry has a saying: there are 2 types of pistol designs, 1911s and everything else. Everything else tries to be different. Striker-fired actions, polymer frames, high-capacity magazines, double-action triggers. The 1911 remains what it always was: single action, steel frame, 7 rounds. And it remains competitive with pistols designed in 2020. Because Browning understood something modern designers sometimes forget: reliability comes from simplicity, durability comes from overbuilding, longevity comes from designing for the real world, not the ideal world, and real-world conditions are messy, dirty, imperfect. Just like Browning's tolerances, Harold Mitchell understood this by 1943. He understood why those loose clearances worked. He understood why Remington Rand's straight-line manufacturing succeeded where traditional gunsmithing methods struggled. He understood that Browning had designed a product for an industrial age, not a craft age. But Mitchell also understood something else, something that took him years to fully appreciate. Browning had not just designed a pistol, he had designed a philosophy. The philosophy that good enough, made consistently, beats perfect made rarely. That reliability trumps precision. That simplicity enables mass production. That designing for worst-case scenarios creates weapons that excel in all scenarios. This philosophy won World War II, not superior German engineering, not Japanese martial spirit. American industrial capacity, building good enough equipment in overwhelming quantities, Shermans instead of Tigers, Liberators instead of Lancasters, M1911A1s instead of Lugers. The sloppy pistol that outproduced, outlasted, and outperformed every competitor. By 2020, more than 100 years after adoption, the M1911 had achieved something no other firearm ever had. It had transcended its military origins to become an icon, not just a gun, a symbol of American pragmatism over European refinement, a symbol of reliability over perfection, a symbol of what happens when you design for how things actually work instead of how you wish they worked. Collectors pay tens of thousands of dollars for original World War II production pistols, Gunsmiths build custom versions costing more than most rifles. Competition shooters win championships with 1911s. Concealed carry permit holders trust their lives to them. And somewhere in Afghanistan or Iraq or Syria, a special operations soldier is carrying a modernized 1911, trusting a design older than his grandfather to keep him alive. Because it still works. It has always worked. And John Browning's deliberately loose tolerances are the reason why. The lesson of the M1911 extends far beyond firearms. It applies to any mass-produced product, any tool that needs to work in imperfect conditions, any design that needs to be manufactured by multiple suppliers. Tight tolerances feel right. They feel like quality. They feel like craftsmanship. But they are expensive to manufacture. They require skilled labor. They do not tolerate wear or damage. They fail in dirty conditions. And they cannot be mass-produced by companies that make typewriters. Loose tolerances feel wrong. They feel sloppy. They feel like compromises. But they are cheap to manufacture. They can be produced by semi-skilled labor. They tolerate wear and damage. They work in filthy conditions. And they enable mass production by anyone with the right specifications. Browning chose loose tolerances, deliberately. Not because he could not design tighter, not because he was cutting corners, but because he understood that a pistol's job was to fire reliably in combat, not to impress machinists with precise fits. The machinist looking at a 1911 sees sloppiness. The soldier carrying a 1911 sees reliability. Both are correct. But only one perspective matters when your life depends on the tool. Harold Mitchell learned to see with the soldier's eyes. It took him months. It required shutting down his production line and relearning everything he thought he knew about manufacturing. But once he understood, once he truly grasped Browning's genius, Remington Rand became the best 1911 manufacturer in history. Not because they built the tightest pistols, because they built the right pistols. Pistols that matched Browning's specifications exactly. Pistols that trusted the designer's vision rather than trying to improve it. Pistols that were deliberately, intentionally, perfectly sloppy. 2.7 million M1911 and M1911 Aoni pistols were produced during the pistol's military service life. That number does not include commercial production. It does not include foreign military production. It does not include unlicensed copies made worldwide. If you count everything, the total production exceeds 10 million pistols. 10 million copies of a design that succeeded because it was designed to be copied. Because its tolerances were loose enough that anyone could manufacture it. Because John Browning understood that the best design is not the design that cannot be improved, it is the design that does not need to be improved. The M1911 did not need improvement, it needed understanding. Understanding that took American industry 40 years to fully achieve. Understanding that Harold Mitchell gained while standing in front of a Blanchard grinding machine, holding two slides with different tolerances and identical performance. Understanding that sometimes sloppy is perfect. March 1943, Syracuse, New York. Harold Mitchell held two pistol slides and finally understood what he was seeing. The tight slide was beautiful. The loose slide was functional. In peacetime, you could debate which was better. In war, there was no debate. The loose slide would still be firing when the tight slide had jammed from mud, blood, or sand. The loose slide could be made by semi-skilled workers in 6 minutes. The tight slide required a master machinist for 45 minutes. The loose slide's parts would interchange with any other manufacturer. The tight slide's parts only fit one specific pistol. John Browning had designed sloppiness into the M1911 deliberately. Harold Mitchell finally understood why, and that understanding transformed American manufacturing, not just in firearms, in everything. The lesson was simple but profound. Design for the real world. Design for imperfect conditions. Design for mass production. Design for the worst possible scenario, because if your product works when everything goes wrong, it will definitely work when everything goes right. The M1911 fired 6,000 rounds without a malfunction in 1910. It fired 6 million rounds without being retired from service. It fought through 10 decades of warfare. And it did all of this because one genius designer understood that tolerance is not about precision, it is about tolerance. The ability to tolerate dirt, damage, wear, imperfect maintenance, and still function. The ability to tolerate being made by companies that made typewriters, sewing machines, and office equipment. The ability to tolerate being carried by millions of soldiers who just needed a tool that worked. John Moses Browning died in 1926, 15 years after his pistol was adopted. He never saw World War II. He never saw Remington Rand's production lines. He never saw Harold Mitchell's revelation. But he knew. He knew that someday, somehow, his deliberately loose tolerances would enable mass production on a scale he could not imagine. He knew that his sloppy pistol would outlast tighter designs. He knew because he understood the fundamental truth of engineering. Perfect is the enemy of good enough. And good enough, produced in massive quantities, wins wars. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.